Welcome back to my YouTube channel. Today I will solve a question of a JAM exams. Okay. Question is given that M and R be the real vector space of all n cross n matrices with real entities. Okay. Where n greater than equal to 2 and any A belongs to M and R, and consider the set W which is spanned by the identity matrix a square dot dot dot. Okay, this set. Okay, spanned by this set. Okay, then dimension, find the dimension of the W. Okay, now solution. Here given A belongs to M in R, that is A is a n cross n matrix which entities from the real field. Okay, and we already know that every matrix have a characteristic polynomials. Okay, so let CHAX is a characteristic polynomial of the A. So that is form as sum an x to the power n plus an minus 1 x to the power n minus 1 plus dot 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 plus a1x plus a naught. Okay, where a not equal to 0. Okay, and we also know that by the Cayley-Hamilton theorems every matrix satisfies the characteristic polynomials. So that is CHA equal to 0. That means an a to the power n plus an minus 1 in a to the power n minus 1 plus dot 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 plus a1a plus a not equal to 0. Okay, 0 matrix. So this we can written as an equal to an minus 1 by an minus, okay, a to the power n minus 1 plus minus dot dot minus a1 by an a, okay, minus a naught. Okay, we also written as this is cn minus 1 a to the power n minus 1 plus dot 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 plus c1a and plus c naught, where cn minus 1 equal to where ck minus 1 equal to k minus 1 by minus an. Okay, so a to the power n can be written as a linear combination of the set identity, okay, and here also identity in, and so a to the power n can be written as a linear combination of the set identity a dot 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 a to the power n minus 1. Okay, now also we can written a to the power multiplying both side a against. Okay, we can find here a to the power n plus 1, that is equal to cn minus 1 a to the power n plus dot dot plus c1 a square plus c naught a. Okay, here put the value of the a to the power n, and also we can written as some coefficient of the a to the power n minus 1, okay, and plus dot dot plus some coefficient of the a and plus also some coefficient of the in. okay, also written as the linear combinations of the identity matrix A dot 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 A to the power n minus 1. Okay, so we can retain every element of the W in the linear combinations of the I A dot 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 A to the power n minus 1 in this similar process. Okay, so that means W equal to span by set identity A dot 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 A to the power n minus 1. Okay, since every power of the A to the power n, okay, can be written as the linear combination of the identity A dot 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 A to the power n minus 1. Okay, this set. So W is a span by the set identity A dot 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 A to the power n minus 1. Okay, and and we know if V is a vector space which span by the set some S, okay, where S is a, where S equal to x1 comma dot dot xm, okay, then dimension of V less than equal to m. Okay, so here dimension of the W less than equal to n, since number of element is n here. Okay, so here we already have dimension of W less than equal to n. So option A is discard, also option B discard, and now check option number C. Option number C say that it is exactly n. Okay, so by counter A is choose n cross n nilpotent matrix. Okay, with nilpotency suppose 3. Okay, so this set identity A, so that means A to the power Q equal to 0 because nilpotency 3, and also A to the power 4 equal to 0, and so on. So that means that is identity A square 0 0 dot dot 0. Okay, so here, so we have this set is not Li, linearly independent, because 0 vector contain in this set. Okay, and we know that every linearly independent set cannot be contain 0 vectors. So here dimension of W in this case less than n, that is less than equal to 3. Okay, in this case. So from this counter the option number C is also discard. So answer of the question is D.